Okay, welcome to Chapter 10, and our first look at Chapter 10 is just going to talk about the difference between growth and growth rates. And to do that, this first page of Chapter 10 will ask you to look at a sentence, look at some growth, and say whether it's constant growth or a constant growth rate. So this first example says that my hometown loses 5 people every year. Now that's counting people. That's a constant amount of growth. You can say that the growth is -5. The second question says the profits of a corporation have grown at 5% per year for the last decade. That percent means that we're looking at a growth rate. That's a constant growth rate. The amount of coal burned worldwide grows at 3% per year. That's a constant growth rate. Each year she gets an automatic raise of $100 a month. A constant growth. Now on the next page we're going to look at what happens when the growth rate is constant. So here notice that growth rate stays 10% from the beginning of the question until the end of the question. And so we ask the question, what happens when the growth rate is constant? So first off, we figure out what the growth would be in the first year. So we ask the question, what is 10% of 100? Well, 0.1 times 100 is 10. So in the first year, the growth is 10. Well, that means that the population grows from 100 to 110. Now, if the growth rate is constant, we're still growing at 10%. But now it's 10% of 110. 10% of 110 is 11. And at the beginning of the third year, we're now talking about 121 people. The growth rate is still 10%. 10% of 121 is 12.1. So that 12.1 gets added to the 121. We're still growing at 10%, so 10% of 133.1, rounded to the nearest tenth, is 13.3. And of course that takes our population up to 146.4. So notice what's happening here. The growth rate is constant, but the growth isn't. The growth actually had to increase. That is, it had to be larger from one year to the next because as the population grew, that 10% also grew. So we were growing at an increasing rate from 10 in the first year to 13.3 in the last year. So let's take a look at that sentence. A constant growth rate, and rate is the key word there, requires an increase in growth. If the growth rate is constant, the amount of growth has to increase. Now let's look at another example. So taking a look at this first example, we're asked what happens when the amount of growth is constant. So here the growth is 10 people every year. So notice how in the first year the population went from 100 to 110, then 110 to 120, 120 to 130, 130 to 140. And so we ask the question, what must the growth rate be? Well, in the first year, notice that 10 is 10% of 100. So the growth rate in the first year was 10%. Now you can do this in your calculator. Just ask the question what growth rate 10 must have been to if we started with 110. That is 10 divided by 110. And if you do that arithmetic, you learn that that is 9.1%. We're asked again to have to round to the nearest tenth. So 10% growth in the first year, 9.1% growth in the next year. Now we're looking at what happens when the population grows by 10, but it starts at 120. So that's 10 divided by 120, and that gives us a growth rate of 8.3%. Notice that the denominator is growing, but the numerator is staying the same. So those growth rates are getting smaller. And we can see that's going to continue into the future if that growth is constant. So now we're taking 10, dividing it by 130, and we're getting 7.6% growth. So take a look at this. If the amount of growth is constant, so this town's population is growing by 10 people every year, And if that's what's happening, then notice that perhaps more importantly, that means that the growth rate has to be going down. The only way that growth can be constant, that is, the only way that we can have a constant amount of growth, is if the growth rate is decreasing. So constant growth requires a decreasing growth rate. So a nice reminder of how growth rates and growth compare. So a perfect introduction to Chapter 10.